Hi, this is Kevin Trainer, and welcome to my lecture for Chapter 1 of Murach's MySQL book, 3rd edition. And let's take a look at what we have. That's better. I typically leave the objectives for you to read yourself. These You can typically in my course, you can read the slides because I give these PDFs of the slides to my students. Okay, so what's this chapter about? Well, this chapter is an introduction to basic concepts that are important for our course. Okay, um, and one kind of general topic is what's the architecture of systems that use relational databases? Okay, and uh, that's the first topic that we're going to talk about. Um, the next thing is how are relational databases organized? And what kind of features do they have? And sort of an overview of the kind of things we're going to learn about in the course. Okay? Okay, so here we're working on the former, which is uh, what kind of architecture do um, systems that use relational databases have? And most of them have some kind of client-server architecture, which is what we're showing here. And client-server architecture is um typified by a, uh, a network connecting a number of computers. Um, and some of the computers on the network are playing the role of client, and one or more of the computers on the network are playing the role of server. Okay, and it's really natural for a relational database to be implemented as a server in a client server system. So that's what we have. Okay, so this is a pretty simple diagram. We're not claiming the network is the internet. Okay, so I guess it could be a local area network. Okay. So there are three hardware components of a client server system. There are clients, um, typically PCs that are on our desktops, okay, or laptops that are on our laps or uh, on the table in the coffee shop. There are servers, and these again are typically beefier PCs, uh, beefier computers. Okay, they could be a lot stronger than PC that run the database server software. And then we have the network that connects them up. And let's see, we could have a local area network. I talked about that already. That would typically cover um, hmm, a small to medium sized office, uh, a home. Most of us these days, or a lot of us these days, have a local area network in our home. We call it the wireless network, but it's a local area network that's just not wired. We have a wide area network, and wide area networks cover more geography than local area networks, and that might be a large office building, or a whole campus. Okay, and to a certain extent, the internet is the ultimate wide area network, right? It covers the whole globe. And what's an enterprise system? An enterprise system is a system used by a relatively large number of users. Okay, so what what kind of systems have we got that are not enterprise systems? One thing that I think we'd like to contrast with are single user systems. So we have a number of single user systems that we're not really sharing with other people. Um, a really good instance of that would be a plain old spreadsheet application or a plain old word processing application. We're working on one document at a time, all by ourselves, not sharing it with other people. An enterprise system, on the other hand, would typically allow multiple users at the same time, um, and would take care of problems like multiple users attempting to access the same data at the same time. And it would be robust enough to do reasonable things to resolve competition and conflict among these multiple users. Okay. Now, in a client-server environment, uh, how do how does a client uh, cooperate with a database server? Okay. Well, it's pretty straightforward. The interface works like this. Um, the client sends across the network, it connects to the server, and it sends a query. Uh, and when we say query here, uh, in fact, we say SQL query, we mean in its kind of widest sense. Of the SQL statements we're going to learn about, some are queries per se. They are SQL selects. So you're posing a question about the data and you're getting a result set back. Okay, so and some are SQL statements that interact with the server in to do other things, to create a new database. Um, to insert some data into an existing database, those kinds of things. But people typically think of their interaction with databases to be query-like. And in those situations, the client computer sends an SQL query, an SQL select statement, and it gets back a result set, and the result sets are typically tables of data. Okay. The other thing that can happen, it's not really explicitly said here, is that there can be some other SQL statement or statements sent to the server, and then the server will send back a response like, I ran that command and it ran okay, or it ran with a warning, or it ran and produced an error. Okay. Now, in this pretty simple client-server architecture, um, all of the business-oriented software is on the client. Okay, so uh, we have a pretty beefy client that um, does all the application and business logic, and then we have a server that just manages the database and our interaction with it. Okay, um, is that good? Well, yeah, that's pretty good. It's pretty good at managing the sharing of the data by multiple users. It really isn't up to that enterprise kind of a level that we talked about before. Okay, so it's a step above uh, single user systems. Okay, this would be um, a multiple user system for maybe a small number of users. Okay. For instance, this would not be a bad architecture for um, hmm, 4 or 5 people uh, who are working in a small medical practice. Okay. Not a whole lot of users, not a whole lot having to be done to moderate the needs of users as they might compete with each other. Okay, let's go on a bit. So, server software. Okay. Um, Typically, for a long time, databases have been installed on servers, and we have some kind of a database management system, and it has a server component, and it does um, all of the processing for the database. So the clients do the requesting of the work to be done, and the servers do the work. Okay. Some people would say that some people would call that work done on the database at the request of the user who's on the client. They would call that back-end processing. So what kind of client software is there on the client machine where the user is going to be sitting? Well, there's application software. There's the data access API, which is an application programming interface. And the client software is doing the front end processing. Now, what is the interface or the API between the client and the server? Well, it is SQL, structured query language. Okay, and again, what I've already said, when the DBMS receives a query, it provides a service like returning the requested data, the query results to the client. And for a proper query, which is an SQL select statement, when it succeeds, it always returns a table. So the answers, this thing called the result set, is a table itself. SQL stands for Structured Query Language. Uh, People call it both SQL and SQL. And people like me kind of alternate using one or the other when you least expect it. So SQL or SQL are both acceptable way to pronounce that acronym. Now, what we have here on slide 9 is a more realistic current architecture for a client-server system that would use a relational database. Okay, so we have the client, which again is quite often a PC or laptop or something like that. We have an application server, and then we have a database server. Okay, so the client in this case is running a pretty simple program, maybe something like a browser. Okay, the application server um, is doing the work of the application itself. So oh, maybe this is an application that keeps track of um, information for a medical practice, or maybe information for a university about students and courses and sections and instructors and who's registered for what, okay, or who's teaching what, those kinds of things, all right? And so, and then over on the right side, we have the database server. Now this kind of three-tiered client-server architecture is particularly good at one um, one kind of interesting implication of this is that the application software itself doesn't actually reside on the client machine. So one of the convenience is you don't have to go out to every PC in the organization where somebody's going to use an application and install the software for it. You typically go install a browser, and typically they already have a browser, right? So they have an operating system and it has a browser, and they know how to connect to web applications um, by typing in the URL that they're interested in. And the application server, which doesn't have to be a web server as well. I mean, we don't have to do this with a browser, but typically that's what we do today. The application server can do a couple things. One, it can do all of the real heavy work in terms of the application and enforcing the business rules. Um, the other thing it can do is it can make sure that multiple users who are trying to work on the same information get to do that in some kind of orderly way. You know, they don't interfere with each other. And then, of course, the management of the data itself, it passes off to the database server, which is running a relational database. So in this world, there's a lot of little clients, kind of PCs on the desks of the users. There's an application server, which is probably a pretty beefy machine. And then there's a database server, which is a beefy machine, which could be the same size as the application server, or maybe a little bit a smaller, or maybe even bigger if it serves a lot of application servers. Okay, so this is a pretty modern version of a client-server architecture, which we call three-tier client-server architecture. Okay, and in order to think of this as a web application, okay, you just have to add some more details. So here we call this a simple web-based system. And what are we doing? Well, we're saying that the network between the client and the web server and the application server um, uh, let me back up. The middle part here, which is labeled web server, web applications, web services, we've got one server in the middle that is probably a pretty beefy machine, which has a web server on it, like a Apache web server, Internet Information uh, server, um, what we call an HTTP server. Okay, and that gets requests across the internet. Okay. And we also have what we typically call an application server, which runs kind of side by side with it in the same machine. Okay. So then we're going across the internet with the client. and we get requests from the user, and that gets sent to the web server. And then there's a response that comes back from the web server, and it goes to the client. And when the components of this interaction between the client and the web server application server, when these are web components, they're pretty standard. Okay, so browsers actually send this thing called an HTTP request, and web servers, HTTP servers, send back a HTTP response. So what's in the request? Well, there are simple requests. If you click on a link that has a URL in it, there's a request that's called get that says get me this page and here's the URL. Okay, so the response for that is just the HTML for the page, and it comes back. If it's a more complex kind of request, like we want to add data to the application by filling out a form and clicking on the submit button. Well, the kind of request that comes from the browser is usually something a little more complex with more data on it, called a post. And so then the HTTP server and its companion application server, they actually do the work. Okay, let's say we wanted to add a new patient. They do the work and they put together patient data. And from that web server that we see kind of in the middle here with the green world icon, to the extent that we need to save data, well, we send SQL commands to the database server. Not a query per se, we send inserts. Okay, and that's how we get the data into the database. And then the results that come back from the database server are more confirmation oriented. They say, you know, that insert that you just sent, that succeeded. Okay, so when the web server application server combination sees that all the work is done, what kind of response does it send back? Well, it sends back a web page. Okay, and how does it get the web page? Well, the program composes it, and it puts it in the response, and we send it back to the browser and the client, and it displays the page. So this is an internet based three-tier client server system. And these are pretty pretty popular. Okay, most web applications that you interact with, everything from you know, Facebook to online banking to sites that give you the news like the BBC or somebody like that, have this kind of architecture. Okay. All right. So it really doesn't matter for our course whether you are, what kind of architecture you're actually working on. Okay. The kind of person who takes our course wants to do, wants to learn how to interact with the server. Okay. They want to interact with the database server. And they usually have one of two motivations. Either they're a super user, okay, And so they want to, for instance, they want to do queries that are not already canned into the application, right? We may have an application where you're able to able to easily display a list of uh, patients, and you're easily able to look at the detailed information for a single patient. But what if you wanted to do some kind of analysis of long-term trends with patients or something like that? And for right now, let's not concern ourselves with the fact that their information might be confidential, which it probably is. Okay. Well, then you might be a sort of a data analyst or a super user who can't really get all the detailed questions that they want answered from the pages that make up the uh, the system. Okay, those are probably not standard reports that come out of the system. So what would they do? Well, they use the kind of tools that we work with here. We have a very simple client called MySQL Workbench, in which we can code in the queries that ask these more complex kinds of questions, and then the server will send back a result set. It'll send back the response. So that's a large proportion of the people who take my course. They're going to be kind of super users, right? They're going to be data analysts, those kind of things. The other kind of people who take my course are going to be the kind of people who build these web server applications. Okay, and when they write uh, the code that they write for those applications has to be able to get the request that comes in from the browser, and they have to be able to interpret it, and then they have to be able to decide what kind of changes we want on the database, and they have to be able to send the SQL commands uh, over to the database server. They have to be able to interpret the responses, and then they have to be able to compose a web page to send back to the browser. Okay, so some of my students are going to do those kinds of things in their jobs. So they have to know how to interact with the server. They have to know how to code SQL. Um, but some people won't do that. Okay, that's not what they're motivated to do. But still, as a super user of relational databases, they're going to want to interact with the database as a database. And so they come to my class. Okay, so that's probably you're one of those two groups. Okay, so the next couple of slides show us some data that's come out of the databases that come with the textbook. Okay, and this, I think we'll make it a little bit bigger so you can see it. Okay, so this is a query, a select, that was run on the AP database, accounts payable, and the result set is what we see here. And one of the things I mentioned, whenever you do a select, which is the SQL statement that is a query, the answer that you get back is always a table. Okay, it has rows and I'm sorry, it's rows across and columns up and down. Okay, so we're seeing 12 of the rows. Okay, we're seeing a slider on the right hand side, so there's probably many more. Uh, this is a list from the vendors table, and I think there are something like 122 or 123 vendors, so we're only seeing about a tenth of the rows. If we pulled that slider on the right down, we'd see the rest of them. And we're also not seeing all the columns. There's a slider down the bottom. If we pulled that to the right, we would see the rest of the columns. Um, one of the columns is particularly important. It's the vendor ID, and it serves as the primary key of the table. It's the one column that makes each of the rows unique. So each of the rows has a column or a combination of columns that uniquely identify that row. And then there are columns that are more typical, just data columns. They're not keys. And here the ones we see include the vendor name, vendor address 1, vendor address 2, vendor address 2 being stuff like the PO box or the apartment number or something like that. And then the vendor city, we assume we'd got vendor state, vendor zip code, all that. Okay, so that's what we're looking at here. Um, oh, I didn't go to the next slide because I made that big. Sorry about that. Okay, well, we'll see if that works. Sure. So here are some terms. Relational database, these are table-oriented databases, and that's what we're learning about. Uh, one database typically has a quantity of tables. One table is organized into columns and rows, and we saw those in the picture that we saw. The combination of a column and a row is sometimes called a cell. That's what you would call it on a spreadsheet. And whereas we don't always use that terminology in relational databases, we do sometimes. Uh, the primary key is again either one column or a combination of columns that uniquely identify the rows. Uh, a composite primary key is just a primary key that's composed of more than one column. A non-primary key is a concept that says some of those other columns, even though they're not the primary key that we use to organize the table, they are unique per row. And we have a feature in relational databases where we can ask the server to make sure that whenever we add a row, that not only the primary key is unique in the data that's in that table, um, but a non-primary key field is also uh, kept unique. Relational databases have indexes. Uh, what's an index? Well, it's like a backup book index. Okay, it helps you find things without a backup book index in a book helps you find things without having to go through every page. Okay, uh, an index in a relational database table allows you to find the row that you want without having to scan through the entire table. Okay, and so what do we do? Well, we typically create a separate file, and we we keep a list of the keys and the rows where that key value uh, is used, and on the basis of the keys, we can get the server to retrieve the row. Okay, it's a very back book index kind of organization. Uh, we have relationships between tables. Okay, and here, again, I'm going to make this a little bigger. So we've got two tables here. The top one is the vendor table. Okay, we're probably seeing all the columns in the vendor table, and that's a result set that's come out of, this is the way that they look when you do a query in MySQL Workbench, which we're going to be using. And the table on the bottom is the invoices table. Okay, and here's the relationship between them. Okay, in invoices, every invoice is for a particular vendor. Okay, and remember, this is accounts payable. These are the invoices that our organization has to pay. Okay, so invoices of this type are not associated with customers. They're not people who are going to pay us. They're associated with vendors. These are goods and services that we consumed, and so we're going to pay the vendor. So rather than keep the the vendor details associated with the invoice on each invoice, the approach we take in relational databases is we simply have a key, this vendor ID, that points to the row in the vendor table. And then if we want to know the details, in this case, it's vendor 123, which is Federal Express Corporation. And we can see their address and we can see their city and all that kind of stuff. This keeps us from having to keep duplicate information in each of the invoices, okay? Because the only thing that we keep in the table for the invoice is just the vendor ID, okay? And then we only have to keep the particulars for the vendor in one row on the vendor table, okay? Now, how does this relationship work? Well, the vendor table has a primary key. You can see that Federal Express Corporation has a primary key of 123. And then when we use it to connect these two tables, the invoices table to the vendors table, this column vendor ID in the invoices table is called a foreign key. Okay, and what's a foreign key? Well, it's a column, and the value that you put into it, into the cell, that column value for a particular row, it points to the row in the other table that we want to connect. Okay, and you can see that all of these invoices that we've highlighted are associated with Federal Express. Okay, and that allows us to do a couple of things. One is that we can ask the question on a query. We can say, show me all the invoices for Federal Express by saying where vendor ID equals 123, and then we'll get the ones that we see. The other thing is that we can create we can do a query that says, show me for each of the invoices, create a listing that includes the details like the vendor name, the vendor address, and all that kind of stuff. And without having to have kept redundant information in the rows of the invoices table, we can do this thing we call a join, and we can pull the information off of this row for primary key 123, and we can get a result set back from our query that has a lot of redundant and duplicate information, which is in a user-friendly format, but we didn't have to store it in a redundant way. We were able to store it in a really compact and succinct way because the only place where we're keeping the details for Federal Express is in that one row of the vendors table. So it's pretty cool stuff. Okay, let's try to go to the next one. So some key terms. The foreign key is foreign keys work this way. They are columns on our current table that we use to connect to another table, and the value that we have in the foreign key is always the primary key of the table that we're pointing to. And typically they have the same name. Okay, so if we look back to the prior slide, we can see that the foreign key column on the invoices table is called vendor ID, and that's the same as the name of the primary key on the vendors table. Okay, there are some situations in which we put a modifier in front of that primary key name, and we won't be dealing with that for a number of weeks. But when the time comes, we'll show you that we can have a slightly different name, but typically the names are the same. Referential integrity is a principle of relational databases that says a database that has referential integrity, when you're going through a table and it has a foreign key column and you find a value, a database that has referential integrity, that value will always be in the table that you're pointing to. Okay, you can't say delete the row in the pointing that you're in the table that you're pointing to. Okay. When you go to insert a row in the table that has the foreign key, and you say it should point to a particular row, like the row for Federal Express, the database management system will actually go and see if there is a row there. So if in fact you go to do an insert and you say that you want to associate the row in the table with the primary key with a particular row in the primary key table, and that row is not there, well, then you'll get an error. You won't be able to put the row in the foreign key table unless you have a row with that value in the primary key table. Likewise, if you go to delete a row from the primary key table, and it turns out there is a row or rows in the foreign key table that are pointing to it, it won't allow you to delete it as long as things are pointing towards it. And that's called maintaining referential integrity. The kind of relationships that we have between tables are one-to-many, one-to-one, many-to-many. So one-to-many is kind of easy. We'll back up here and we'll look at this. It turns out that between vendors and invoices, there's a one-to-many relationship. Okay, one row in vendors can be associated with many rows in invoices. Okay. Now, how do we implement that? Well, we implement it with these foreign keys. Which table does the foreign key go on? It always goes on the many side because you can only point to one row. It's not possible to point to more than one row in an effective way from the primary key side. So the table with the foreign key is always the many side. Okay. And each of the rows can point to one row in the one side. Okay. That's how that works. You can have a one-to-one relationship, or you can have a many-to-many relationship. Now, one-to-one is kind of interesting because truly one-to-one relationships are rare. If you have a one-to-one relationship, you're often talking about the same thing. So I teach you in my course to be a little suspicious of one-to-one relationships. We do have them. They're just not so common as people would think. And many-to-many relationships are interesting. They're not implemented directly in relational databases. We have to add a linking table in between. And we're going to learn about that as we go through the course as well. What we're seeing here is we're seeing a page, a screenshot from MySQL Workbench that shows, I think, the columns. So these are the columns on the invoices table, which is why the title might say the columns of the invoices table. Sorry about that. I didn't read the title. Okay. And when we learn how to use Workbench, we'll learn how to use that feature. Common MySQL data types. So every column has a type. It's only able to hold one kind of data. The most general data that we can have is character data. And we've got two types, char for a column that has a fixed width, and varchar, or as somebody said, as people say, some people say char and varchar. I don't. I say char and varchar. But a varchar has a variable length, somewhere between 1 and 255. Well, actually, the fact is you can give a varchar column an empty string, so somewhere between 0 and 255 characters long. In terms of numbers, we can have ints, they're integers, decimals, they've got a fixed number of decimal places, very good for dollars and cents. We have float for floating point, so they're numbers that have a representation scheme that's kind of based on scientific notation. The good part is that you can represent values that are very large and values that are very small. The bad part is that we don't keep the number of digits of precision. They're really not all that high. So on one hand, you can do very small and very large values. On the other hand, it can be challenging to keep track of something like getting the cents to always work out with dollars and cents. Date, there's a date type and a date time type. They're very interesting, and we learn about them in the course. Terms to know about columns, data type. Every column has a data type. Null values, okay? There's a special value that can go into a cell, row column combination that says there's no value here, okay, which is kind of a lie because there's a null value here. But that the only thing we know about nulls, if we don't give a value for a particular cell, and the rules for that column say it's okay to have null values, well, then it will put in the null value, and when we get it back, we'll be able to detect it as a null. We try to keep away from that stylistically. We'll discuss that and learn about that as we go. We can have default values, which are to say when we go to insert a new row, if we don't provide a value, and it turns out that that particular column has a default value, like 0 or 1 or 99, well then it'll use the default value. And we have a really cool idea that's called auto increment. And this is really helpful for uh, columns that we want to be primary keys, and they're just a series of integers. The first one's 1, the next one's 2, the next one's 3. These are kind of arbitrary numbers that we apply to something to make sure they have a unique key. We can give that column the auto increment specification, and the server will keep track of what numbers have been used and always give you the next one when you insert a row into the database. What we're looking at here is an entity relationship diagram. Entity relationship diagrams are typically used for conceptual data modeling, logical database design, and physical database design. So they're used in the design process. They're also used as a way to document the design of a database that already exists. And what we're looking at here is we're looking at an entity relationship diagram for the AP database. That's one that we're going to use a lot. And this was actually created by using a feature of MySQL Workbench, where we pointed Workbench to the schema script for the AP database. And one of the things we can ask it to do is to draw the diagram for it. And I teach my students to keep these handy for the databases that they use because it makes it a whole lot easier to figure out how to do a query when you can see the design in such a graphical way. Now, there's a standard for SQL, okay? There have been a series of standards for SQL. The standard for SQL is a part of a series of standards that come from the American National Standards Institute, or ANSI, ANSI. And they're what you usually do is when you refer to a particular version of the standard, you use the name ANSI and the year of that edition of the standard. Now, what's the good thing about standards? Okay, well, the basic statements that are part of the standard are the same in all relational databases. Okay, so that makes your code more portable from one database management system to another. On the other hand, why that doesn't solve all your problem? Well, because of the fact that we typically use some of the proprietary features from whatever relational database product we're using, because it's very hard to not do that. Whenever you need to move your database from one relational database a product to another, you will have to change some things. It's not reasonable to expect that you can do everything that you want with the standard features. but you ought to stick to the standard features as much as you possibly can. So that'll mean that any migration from, say, MySQL to Oracle, or from Postgres to Microsoft SQL Server, it won't be pain free, but to the extent that you concentrated on using the parts of SQL that are part of the standard, you'll confine the pain to just a couple of things that need to be converted. Here's some stuff about the history of relational databases and SQL. I think what's interesting to know is the first commercial relational databases were coming along. Oracle was out in 1979. DB2 from IBM came out in 1985. Things the Microsoft SQL Server 1987. MySQL, which is what we're using in our course, came out in 2000. Okay, so commercially available relational databases have been around, say, since 1980. That's now 39 years ago. Okay, now their capability and their performance has improved dramatically. We have products like MySQL that are free and highly capable. But the fact is, we're using a technology. It's a very popular, very robust technology, but it's 40 years old. Okay, and the way some of the features work or don't work, a lot of times you can explain by just how old the technology is and what the expectations for feature sets were in 1980. Okay. SQL or SQL, which again I say interchangeably, has two groups of statements. The ones that we're going to learn first, which are called the DML, the data management language. That's the select. That's where you get a query, and then insert, update, and delete, where you add, change, and delete rows in the database. And then we have the DDL statements, the data definition language. And these are where we write SQL to either define a database and its table and its indexes, or we alter it, or say we drop the database, the table, or the index. Okay, and we're going to learn how to do all those things. So if we wanted to create a new database, we could write SQL like create database AP. Okay. Now, I'm going to tell you that in our class, we're always going to put a semicolon at the end of any SQL statement. Well, why do we do that? Well, it's actually a separator, so you need it whenever you have more than one SQL statement. And one good kind of programmer trick is whenever you have something like this, where if you go from 1 to 2, you need a semicolon at the end. Put the semicolon on all the time, okay? Because the number of times that you come back and realize that you're going to have 3 statements instead of 1 is really high. Okay, so that's what we're going to do. We're always going to put a semicolon at the end. Okay, when we say use AP, we're telling the server that the statements that come afterward all relate to the AP database. Here's so Here's some DDL. Here is a create table, which is part of the DDL, where we're creating the invoices table. Here is a statement that adds a new column to a table. So we've already defined the table, and we say it's called invoices, and then we want to add a column balance due. That's a decimal with 9 places overall, 2 of which are to the right of the decimal point. This is a statement that deletes the new column. So again, we say we want to alter the invoices table, and we want to drop the column balance due. Here's a statement that creates an index on a table. So we're creating an index, and we give it a pretty useful name. And this is an index on the invoices table, and the field is the vendor ID. Here's a statement that it deletes that new index. We say drop index, and we use the same name. Okay, so we'll do all that kind of stuff towards, not quite at the exact end of the course, but towards the end of the course when we're learning the DDL, the data definition language. So having done all that kind of stuff, we have the invoices base table. What's a base table? It's a plain old table. We do have some situations in which we create these things called views, which kind of pretend to be tables. So they're not base tables. But base tables are real tables, like the invoices table. Now, querying is a lot of things that my students like to do because, again, a lot of my students are going to be, say, data analysts, okay? And so they're going to write queries for the database that pull data out of the system that are not kind of built into just the standard reports that come out of the system. So they're going to spend a lot of time using the select statement. Okay. So we say select, and we have the names of columns, invoice number, invoice date, invoice total, payment total, credit total. Those are all column names in the, we say from invoices. Okay, so they're columns in the invoices table. Well, what's this expression here? This is a calculation. So we can have a column in our result set that's not exactly just the value that's in that column in the table, but it's a it's a manipulation of values that are in the table with some kind of formula. And here it's just one column minus another column minus another column. And then we can give it what we call a column alias. So we say as balance due. So even though this isn't a column that's going to exist in the table, for the purpose of our query and our result set, we are going to have a balance due column, and it's going to be created using that formula. We can have a where clause, okay, and what we say is that for a row in the table to appear in the result set, it has to meet the criteria expressed in the where clause. And these criteria say that the balance due has got to be greater than 0. So we don't want to see things that we've already paid. Again, remember these AP invoices are things that we have to pay. These are invoices that were sent to us because we got things on credit. Okay, so Uh, if they're if we don't owe anything further, then we're not interested. And we are able to sort these into order. So we were able to sort these into order by the invoice date. And here's the result of the query. You can see that it has um, a column called balance due, even though that's not in the original invoices table, but we are able to create a calculated column and to give it a name uh, with this feature that is implemented with as, and this name is called a column alias. Um, we're going to learn how to do that when we get to chapter 3, what we just saw. Now, to do what we're seeing here, uh, we're going to we're going to need to get to chapter 4. Okay. Well, why is that? Because we're joining data from two tables. Okay, and that's where the real power of relational databases comes along. We spend, in my class, we spend a week on chapter 4, typically, because it's something to get your head around. How to get the data from more than one table in a query. And again, even when you're pulling data from more than one table, you are describing a result set that's a single table. Okay. Typically, it's a table of answers that you want. Okay. And this, I think, really gets the spirit of SQL in certain kind of older database types. And yeah, there are databases older than 40 years. Um, what you would do is you would retrieve all the data that you needed, and then you would process it, and you would do the summarization, or you would do a lot of, say, the weeding out of the values and stuff. With relational databases, you really describe the answer that you're looking for. So pretty typically, you can take the result set that you get back, like we see here, and you can just show it to your users. Okay? It's the answers. It's not the raw data from which you calculate your answers. You can do enough in the query itself and the select itself to get just the answers that you're looking for, not the data from which to compute them. Okay. So terms to know: a query. A query is used in two senses. Okay. In a more general, loose kind of sense, it's any SQL statement, including um, the DML and the DDL. In the most narrow sense, a query is a select. So that's one of the statements from the DML. A base table is just a proper table. Okay. A result table, we typically don't say result table, we say result set. That's the answer set that comes back from a select. It is always a table. Okay. This really elegant aspect of relational databases turns out to be highly valuable. A calculated value is um, for the for a column in a select. Each of these things that we choose, we call it a column specification. The easiest thing to put into it is a column name. The next easiest thing to put in it is a calculation that creates a calculated value column. Joining is when we get values from more than one table in order to satisfy the query. Um, uh, pretty soon, when we get to chapter 4, we'll be doing joins where we're using 5 or 6 tables. Now that'll sound like a lot now, but after we do it, we'll realize there's a real kind of a deliberate way that you learn how to formulate joins on multiple tables, and the next thing you know, it's easy to do. We have 2 kinds of joins. We have inner joins and outer joins. Um, the distinction between them is an inner join is a regular old join in which the criteria have to match all the way across all the tables that we join. And if there isn't a match on any one of the tables, you don't get that row in the results set. Outer joins allow you to say we can have no match on one of the tables. And that allows you to answer questions like the following. You might want one application that I used to teach with. It was about Italian opera. And so we had a query in which we wanted to list every city that we knew about in the database and how many operas had premiered in that city. Okay, and we had enough data to do it, but if in fact we had a city that we knew about, like Poughkeepsie, that didn't have any opera premieres that we knew about, we wanted it to appear. We wanted a line for Poughkeepsie, and then we wanted a 0 value for the number of operas that premiered there. And we can do that with outer joins, and we'll learn how to do that. And it's an important skill that you will come to enjoy. So once you learn how to query or do selects, then you have to learn how to get values into the database. And you can do that by using insert. You insert rows. So here we're inserting a single row, and these are the values down at the bottom that go into the columns. If we want to change some of the values on a row or rows, we use update. Okay? And we can use, for instance, the where clause to control which rows are updated. And the where clause might identify a single row, or it might identify a group of rows, in which case it's possible to change more than one row with the same update SQL statement. The same for deletes. So we can delete a row when the where clause points to only a single row, or we could actually delete more than one row. Here the where clause says we want to delete the rows of invoices that have been paid. If they're exactly paid, they haven't been overpaid, they haven't been underpaid, but they're paid exactly. The balance due equals 0. That's what that formula says. We have conventions for how to format our SQL to make it easy to read. Okay, and as you go from book to book and tool to tool, you see some differences. But what we're going to follow is we're going to follow the recommendations from our author, Joel Murach. And what he follows is an approach that is, how can I say this? It is implemented by MySQL Workbench. So there's a pretty printing feature. It's actually called the Beautify button. And you can take statement like the one up here on the top that's in all lowercase and not indented, not put it in, not put in on different lines and that kind of stuff. And then you can click on the beautify button and it will reformat. It will pretty print it to look like this. And generally what we're going to do it is the keywords from SQL, like select, from, where, order by, are all going to be put into all caps. And then the names of the database objects, like the column names and such, or the table names, they're going to be in lowercase, separated by words separated by underscores, because that's really the current trend. Okay. And then what's going to happen when we learn how to do that is that not only is the case going to be changed on this, but it's going to be put into a format in terms of how indented things are and what line things are on, that makes it easy to read. And I'm going to want you to do that in my course so that when I see your work, it's easy to read. And the only thing that we're going to do on ours, that it's not shown here, is this select, even with all these clauses that it has, is a single statement. So it's going to end down here at the bottom with a single semicolon. We're going to learn about comments, okay? In most programming-oriented language, they have the capability that you can put some comments in to help the reader understand your code. And if you want a multi-line comment, it starts with a /* and it ends with a */. And this is true of many, many programming languages, not just SQL. And if in fact you want a single line comment, you can begin it with a --. And again, this approach is used on in several programming languages as well. So there are recommendations here on slide 34 for how to format your SQL. I talked about a lot of that before. I mentioned it's implemented with the Beautify feature of Workbench. And so I'm not going to go into the details. I'll leave them for you to read, but we're going to follow all of these. Okay. Now, I mentioned that people who take my course generally fall into two categories. Data analysts, kind of people who are really going to be using SQL as SQL. They're not going to be just plain old users of a web application that has a relational database backend. Okay. And that's pretty much what we practice all the way through the course. Okay. There will be people who want to be programmers who are going to write programs that communicate with the database server. And the next couple of slides show for a couple of programming languages what the code would look like in the program. Okay, that's not something that we do in this course. You'd learn that in another course. Okay, so the two programming languages, well, they talk about three here. PHP, which is a web development language, Java, which is a general purpose programming language, and C#, which is a Microsoft general programming language. And they all, when you're working with these programs, you have the the program and the language itself. Then we have some kind of library code, some code that was written by the people at, well, Microsoft, or in the Java case at well, it was Sun and now Oracle. And then we have drivers. So these are kind of general modules, again, probably written by the people at Oracle and the people at Microsoft. But they implement a standard programming interface for um, a conforming relational database server. So at least in theory and often in practice, you're able to take these programs and you're able to port them from working with MySQL to working with Oracle to working with DB2, because they use a standard approach to the interface between the programming language and the database server provided by the DBMS supplier. So I'm not going to talk. There are, sorry, these drivers, okay, that we saw here, one for Java, one for .NET. It says that the one for Java is called Connector J, and the one for .NET is called Connector Net. Okay, and here are some of the here are the names of some of the software pieces that are used to implement the interfaces between those programming languages and products like MySQL. And here is a PHP program that accesses a database. It's doing a query. And the interesting thing that you should know is it just has the SQL code in it, okay? So it puts together a query, okay? What it looks like, just like the one that we're going to learn how to do in our course. We're going to type ours into MySQL Workbench, but what it does is it puts it into a variable, and then it sends it across the net over to the server. Okay, and it's what does it get back? It gets a result set back, and then it starts to probe the result set, typically in order to build a response to go back to the client. Okay, and what does it build? It builds a web page. Okay, and there's a lot of details there. That is the outline of a web page. All right. Now in Java, it's the same kind of deal. So here again, we have a query. We create a query, but what goes into it? Just a plain old select. Okay, just like the ones that we're going to learn how to type in. That's why taking this course is the first step in learning how to be a database programmer. Okay, if you don't know the SQL, well, then you don't know what to put into your program. Okay, am I going to cover the PHP that you need to know in order to write a PHP program with SQL? No. Or the Java? No. But this is how they would fit into those programming languages in order to get the job done if you were to become a database programmer. Okay? And that, I believe, is it. Okay? So that's a lot of information, but what we're trying to do is give you the general lay of the land for relational databases, how they fit into modern information processing, and then give you a preview of the features that we're going to learn about and use. So I'm just going to say goodbye until next time. Bye-bye.